Alrighty. Welcome. Today we are going to, we have some, we finished a sort of parser for the small subset of expressions that the author talks about in chapter 6 that are like arithmetic expressions. And then last time we added errors. So we have a few tests that will make sure it returns the right syntax error if you make a syntax error in your code. Michael, I would appreciate if you could mute.
Oops.
Thanks. Yeah, no worries. So the thing we're doing today is trying to figure out how to expand to the entire grammar of the LOX language, which is a lot bigger than this. And the first thing we are going to try is we noticed that there are a lot of grammar rules of the form this grouping, logic and, is any number of some lower order grouping, like equality, combined with sort of a token that joins them. There are a lot of things that have the same format, like this and this and that. So the first thing we can try to do is write a macro that describes this sort of pattern. And I guess all of these actually follow that pattern. It's just that there is a group of possible joining tokens. So yeah, we can try to do that, and then maybe that will be enough, or maybe we can also try to make macros that are sort of more flexible, like you put in a description of grammar rules like this, and then it gets turned into the Rust code needed to parse it. That might be a little overkill. I'm not sure yet. But the first thing I will try to do is write a macro for this pattern with an arbitrary starting name and ending name, or I guess like higher level name and lower level name, and an arbitrary set of adjoining tokens. And then we can try to replace the pieces of our sort of expression parser that use that pattern with a call to the macro and see if the tests still work. That's the first thing I'm going to do. So let's see how a declarative macro. I believe.
Can you try sharing the session again? I'm trying to log in. It says no longer active.
Yeah, no worries. And then, yeah, you might have to join soon after I post the link, and then I have to say you're allowed. All right. So
is this a so-called macro rules macro, or?
yes, it is. So a declarative macro is macro rules, and then a procedural macro is you you conform to some sort of like format of how your macro is defined, and you manipulate like compiler types, or like AS types inside the Rust toolchain. So let's look at this. Here's their example. I don't really know what macro export. Do I need to import? Okay, we're good.
You don't need to import anything.
Yeah.
All right. Let's see. Guess I can mute as host. That's cool. So their example macro I guess, let's see, how does it work? So this is some sort of, I guess it looks like it's, this is a grouping. So it's detecting, let's see if it explains anything about this. This will be something like you declare a vector literal, and then it replaces it with this code where it makes a vec using vec new, and then just pushes all of the things that it detected in this group, and then returns it. So let's see, how could this work? Star. Let me see if there's a guide to macro rule syntax.
So macro vec takes one or zero or more expression separated by comma and assigns it to variable x. My vec.
Yeah. Okay. So yeah. So this. Let's see, how can it know what type it is? I don't know. So let me do this inside of a function so that
it doesn't know anything about the type. It just does token substitution.
Yeah. But so it won't infer a type for X until, do you have to, is there like a way to have the macro assert the type of the thing that it produces?
If you do it by hand, yes.
Okay.
So one way, the way I usually do the macro, I take the function I want to change to macro and add macro rules around it. Then just replace the bits in the pattern part with what I want to pass and use those inside. So let's take a look at parse comparison, for example.
Sure. So take the body of it and turn it into macro rules?
Yep.
Okay. Let's see.
Well, it's not going to be parse body, it's going to be parse, make parse, for example.
Right. Oh, okay, sure. That makes sense. Make parse grouping. So I'll put it in, and I guess that goes in here.
Yes.
If I just hit Control C instead of Control V. Great. All right. Goes in here. And then
you take everything, including the function name.
Everything.
Yeah.
So we're not. I see. So you want it under our declaration for expression, it'll be like make parse grouping. This.
Yeah.
Okay, that's fine. That's not what I expected. I expected we would have a parse equality, and then the body of it would be make parse grouping. But that's fine.
That might work as well.
So we're returning this literal piece of text.
Yep.
And now we need.
For now, we pass now parameters.
Yeah.
And if you call this macro, it will produce this function.
So the one I copied was parse comparison.
Yes.
So we will do a make parse grouping and see if that passes tests. And it should. Didn't do anything. Okay. So the things that we kind of need here are the
We start with function name. So as first parameter, so patterns take form dollar, pattern name, colon, and pattern type. A colon, it's
And then-
identifier, ident.
Okay, that makes sense. So what are the different types of these things you can do?
Ident, expression, token tree, literal.
There we go.
Yeah, those.
Um,
In that case, we want
Designator.
ident.
so we have function name. We have the function that you call, the lower level one.
Okay.
The I don't know what we want to call it really. The join. We have like the joining function, which is the check. I kind of would like to put in this literal pattern here or something encoding this pattern instead of having to call out to an external thing. Like the try parse comparison.
Well, that's going to be a separate macro, I think. It will take a list of those patterns and return whatever function
Yeah.
does it.
All right. Cool. So yeah. So I'll set it up to be that. Make token comparison. Okay. So this, we need a function name. We need whatever this the called function, the lower level function is. Let's see. No clue. I'll just call it something stupid and then we can go back to it.
Sounds
Constituent
good.
function name ident. And then we need what type of token you need to produce. It'll always be a binary. I guess that's sort of what I should guess. Binary. Okay. So this is literally the function name. And I guess do you also use $1 when you're invoking it?
Yep.
Okay. That makes sense. And then what the other thing we needed to do is it always going to be this? Let me see if this is like an exact match here. Okay, maybe not. That sure looks the same though. This and that and that, those are the same. Okay, I will assume that they are the same. So nothing changes there. And then we need this function. See this, we're only going to use try parse comparison in this place, right? So we have this separately defined try parse comparison function, but we only will ever call it in the parsing for comparisons. So why don't we just generate that code here, right?
What we're going to use in other functions. It might make sense to make some kind of trait and use that.
Okay. What are you doing here?
I'm trying to write the same, but using just plain functions.
Okay, gotcha. Wait, for the whole grammar?
Oh, yeah.
So it's a race. Okay. Okay. So let's just, for now, let's just say comparison function. And I'll pass it in. Okay. And then I will put it under, does macro expansion order matter here? It shouldn't, I hope. Like if I have a macro to make the comparison functions under binary operator, and I do this.
So it will expand the inner macro first, I think.
Right. Okay. But I'm not calling another macro here. I could, but what I was thinking is like, what if under binary operator, we have a bunch of calls to like make token comparison, and then we just refer to the name that we're generating here. Is that legal? I guess I'll just find out.
So macro runs around when it tokenizes stuff. And it just takes the token stream for the what's inside and calls the macro with that and substitutes. So a macro will never see the macro on the inside.
Okay. I'll try to make it. So this is the, let's see, what else can I have? Literal. I sort of want to define the literal list of tokens that it could be.
Literal in context of macro rules are numbers and string literals.
Okay. So it's an expert then.
Yeah.
Let's say adjoining tokens expert.
That is not going to work.
No.
No, for that you need to use paste proc macro, for example.
Okay. Yeah, that I'm just trying to figure out how to refer to this thing. Okay, let's try something. So instead of parse term is now the constituent function name. $sign. This is also an ident. Okay. So if I do this, the function name, oh, and it's not like, okay, it's not a string literal here, right? It's an identifier, so I don't need quotes. So we were
You don't need quotes.
parse comparison, parse term, and then try parse comparison. Okay. And then we'll be doing the same thing with first term, parse factor, try parse, whatever it's called for terms. Plus minus. Okay. And parse factor, parse unary, and then try parse muldiv. Okay, and then unary doesn't follow the pattern. Let me see if I want to try to get to a state where I can cargo test.
Sure. I commented it out.
Thanks. I saw you have 2 arrows here.
Yeah.
Okay. All right, it works. Awesome. All right, I ran the test. You can do what you want. Can I try to replace the comparison? So if I have a separate macro, let me try to do it with separate macro rule. So here I'll take a function name, ident, and I'll take a list of tokens. So let me
maybe instead of that, we just take a list of matches.
List of matches?
Yeah.
Like this?
Well,
or this?
Because, like that.
Okay.
It will have to be proper Rust expression. So in macro rules, in pattern, you'll say something like $path
Yeah.
from path to export, and we expand match this from some to star none.
Okay, I like that. Is that supposed to be an ampersand there?
No, it's supposed to be $sign.
Yeah, okay. Just wondering. So yeah, following this example.
Yeah.
And then is the comma here the separator?
Comma here is a separator. We will have comma as well.
Okay.
That's the dollar sign. That's the dollar sign. What is it? Why you not happy?
You need to name it.
Ah, I need to name it. How about now?
Okay, it's happy. It's happy now, I think. Okay, so you're saying we will to make one of
Just
these.
pass a list of patterns we care about.
Okay. So in here, so I replace this with,
Yes.
why is it a whole bunch of different match? Oh, okay. I guess you replace the match itself.
Yep.
It's always going to be value, I guess. Yeah. Okay.
We'll have to pass the identifier name as well. And then like so.
Okay. And it goes first.
Yes.
Let me see what you've done. So value, and then everything else gets
Yeah.
matched into the pattern. Okay. Do you need to make one of these? Okay, I'll just try it. Let me see what happens.
It's
So
just a comma separated list of tuples.
but it
Oh.
alternates between the from and to. So
Yeah.
okay. I've lost my undos. Okay. Yeah, I guess that's one weird thing with the live share. But it messes with the undo stack. Let's see, so like that. Okay, and then I need the okay. That's okay. I'm pretty sure. Let's see. So all of the ones we happen to be working with here
Okay.
have the
So
same name on both sides. Yeah.
You don't need sum. We substitute it in the macro.
Okay. That's fine. So okay.
And since we have both of those at the same time, I wonder if we can pass just list of tokens. So it would be value, then greater equal, less equal.
Yeah, that's what I was about to say. It's just, I don't know if that's always going to be true. If the token types here are the same as what they are here, it should be, I guess. These are all the different binary. Okay, are they all the same binary operator types in the full grammar? Probably not, right? Yeah, you have or and
we can have more than one macro rules.
yeah. Okay, that's fine. Yeah. So the normal one, we'll make it so that we just say greater like that.
Magic.
Okay. So I'll change the pattern.
Okay, so it's no longer path. It's probably TT token tree.
PT token tree.
Yeah.
Okay. How do you know which one? You kind of need to know the Rust compiler a little bit, right?
So yes, you need to spend some time writing those macros.
Yeah. So
And it's probably no longer from its whatever name is good.
yeah.
Talk. Yeah. That would be yes. Is it working?
Let's see. So I guess, yeah, I replaced one of them. We'll see. Okay. Missing a comma here to end the match arm. Yep, it works. Amazing. Okay.
Well, it's not something I would use in production, but if you want to use macros, that's how we use macros.
Yeah. I'm not really sure. Yeah. Yeah. I'll use it here. If we run into a place where the pattern breaks, then, you know. All right, so patterns, value.
We can change it so we don't have to pass value even. We can
Yeah.
change it to produce lambda function.
Right. Yeah. We just can't, for some reason, we can't generate the whole.
We can, maybe we don't need to. We will have this sparse comparison, but we only use this sparse comparison in the
Yeah. Yeah, that's what I
in
was.
the macro. So we will be passing.
That's what I was saying. So like if you have an, I mean, if you have an inner macro call here.
So this is a comparison function, is it?
Yeah, it is. I guess we put it under binary operator, but it's just takes a token type and returns an option binary operator.
Right, so if you go to the patterns macro we defined, let's change it to produce a lambda function instead of taking the value. So we will be passing only the token names.
Okay, and what are we? What we're producing the function, so now it's called like.
Yeah, so
try
something like this.
Try
match. Probably, yeah.
So right, so value goes to that. And that's the same thing, I guess.
And this we can use in the where we call the macro instead of function name.
Yeah. So self doesn't mean the same. It's not going to be part of the binary operator impl anymore. So we need
to replace self with something more
self
reasonable.
Binary operator. And then we use try match patterns. All right. And we still need to get the token type out of it. So it'll be try match patterns.
Isn't we passing this as a comparison function? So we'll change comparison function to be of ident type, expression type. And that would be lambda expression we will be generating.
I kind of thought we would be replacing comparison function with the patterns. Like
you can pass patterns, but you can pass ready-made lambda.
okay, sure. So a comparison function is now the expression of the lambda. Okay.
And we,
That's fine.
you need to call the macro. It gets us lambda function, and so you need to add extra parents. You need to pass. So.
Oh, call them. No, I'm not calling a macro.
Wait, no.
What?
No. This is correct. Yes.
Yeah.
Okay. Ignore me.
So and then I'm calling the macro in here.
Yes.
Yeah. Okay. So what did we just call it? We called it your pattern, try match pattern.
And patterns we care about.
Right. These. Okay, I like that. Okay. I don't know what happened there. Okay. I will test again. So I'll get rid of that because we replaced it. And then I'll move this. Okay. Do not compile because I got rid of that. And I guess we don't need any of these.
Yep. Just replace them.
Oh, it's going to complain about, yeah. Token type. Okay, now what? I see. Did I just forget one? I did.
Possibly.
And then what do you do here? Yeah, wait, okay. I'm just going to refer to the previous code. Your parse equality, you're separated by try parse equality, which is that. So this. Okay. So this, I kind of thought that would be raising an error. Okay, let's see. All right.
doesn't work. Unexpected UF.
Is one of the is this one different? Doesn't look very different. So I'm referring to this name even though the function's not there yet.
Which test case have we fallen?
Incomplete.
Complete binary.
Yeah. Should be raising an EOF.
Yeah.
Does it work right now? What are you talking about here? Oh, okay. Here's where it's saying duplicate parse equality. So let me take out the macro version of it. Does this work? No. No, because that's not there. Okay, so okay, that still fails.
No. It calls to parse comparison.
Yeah. Did I like mess up one of the checks? Like this one? That should be plus and minus, I think. Yeah.
Yep, that's better.
Okay. So yeah, right. When you parse, yep. Okay. I think this is right. Okay, now I can put this back and get rid of this. Cool.
Okay. Well, I guess we can say it's an improvement if you have a huge grammar.
Right, yeah. So I want, how many more cases like this will we have in the full grammar? Let's see. We have logical and logical or, and then this stuff we already had. And then we have these also follow the pattern. Okay. And aside from that, I think that's it.
Okay, so we committed that. Let's try to generalize it a bit more. So if you open any of the grammar rules.
One sec. I'm just pushing it. Groups, binary questions. Okay. Yeah. Any of the grammar rules?
Yeah, so it is basically either sequential composition or parallel composition. So declaration is either class, function, or variable. And the class declaration is class followed by identifier followed by parentheses. So we can try to represent this somehow instead of hard coding the function name and so on.
Okay. I agree. I'm just so this is parallel composition. This is sequential.
Yep.
All right. So what we kind of need is a way to encode all of these regex like patterns though, right? How to parse each one of them.
Yeah, we can pass literals. So, for example, we can pass like vertical line, we can pass parentheses. But in this case, we will have to change how we write the macro. Right now, we're trying to match everything at once, but it's not going to work. We will have to use the incremental TT muncher. So I pasted the link to a book about proc macros, macro rules. So the idea is we have some state and we're trying to parse elements from the front and shove it into the state somehow.
Okay. Wow, it's kind of like you're convincing the macro rules to be a parser.
Yeah.
That's funny. So we're making a tiny little parser for the grammar rules. Is that right? Is that the idea?
Yes.
Okay. I'll just read this because this seems useful. So this pattern is perhaps the most powerful macro parsing technique available, allowing one to parse grammars of significant complexity. A TT muncher is a recursive macro that works by incrementally processing its input one step at a time. Okay. At each step, it matches and removes or munches some sequence of tokens from the start of its input, generates some intermediate output, and then recurses on the input tail. Okay, recursive macro. Gotcha. The reason for TT in the name specifically is that the unprocessed part of the input is always captured as a TT star. This is done as a TT repetition. Token tree. Yeah. This is done as a token tree repetition. As this is done as a token tree repetition is the only way to losslessly capture part of a macro's input. Does token tree, why is it a tree? Is this like at the AST level of the Rust compiler?
It can contain parentheses, and inside of parentheses there will be a whole bunch of stuff.
Okay. The only hard restrictions on TT munchers are those imposed on the macro system as a whole. You can only match against literals and grammar constructs, which can be captured by macro rules. You cannot match unbalanced groups. All right, macro recursion limit in mind, no tail recursion. That's fine. We're parsing tiny grammar rules. We won't run into that. So what does this actually do? This is like a base case kind of thing, looks like. If your tail's empty.
Just a second.
No, yeah, no worries. All right. There we go. Let's see. So you have trace and tail. All right, So what they're doing here doesn't matter. What matters is that they're consuming one of the things and then recursively calling on the rest, but
Okay, I'm back.
cool. This is neat. So I sort of get it, but I also don't get how where the flexibility comes in. So like you're calling this thing recursively on each part, like each thing in the list that you're passed in.
Yep.
But how do you know what to munch, I guess?
So we'll do it in several steps. So
Is the point to I guess you sort of mirror the recursive descent structure. Like you have more matching rules, right?
yes. So first we take whole structure and we'll call it recursively with some state. Items munch. So at is not a proper part of Rust syntax.
Yeah.
But it is supported by proc macro for historical reasons. It's
all right, cool.
One of the chapters of this book mentioned this trick.
This book?
Yes.
Okay. Munch.
So first,
Is this like an argument to munch, or what's going on here? So
last thing we do is we just call itself with empty expression. Expression is somebody going to collect our results, and items is the input we had. So we have munch. We have expression we accumulated so far. It's going to be rest something that we don't parse. And here we're going to put patterns one by one. Once we know what we're going to do with this pattern,
okay.
We'll call itself recursively. We'll make a new expression. Like do something here. Then we pass
the rest.
Expert 2.
Okay, so expert 2. This is a little bit like a continuation passing. It's reminding me of that. Okay.
So this is the whole approach.
So Wait. But he's not doing that here, right? He's just calling on tail. So he's done something with the first thing.
Yeah.
So also, what's trace mean?
Trace is just literal pattern. It will match for trace specifically, and nothing else.
Okay. So you invoke it like mixed rules, trace, blah blah blah.
Yeah.
Okay. Okay.
Okay, maybe we don't even need to create this fancy state. So I guess first we need to name intent, name
So okay.
whatever, and
So
this
we're going to call how? Can you explain how we're going to call this? So it'll be mixed rules of something like a grammar rule.
yes, so it's going to be, for example, class decal. It's going to be class, going to be identifier.
And what about these sort of like groups? Well, we need a way.
We can use parentheses.
Okay.
We can actually use this exact syntax.
Because you're pattern matching on the
Yeah.
next thing you're munching. Okay. That's
Yes.
funny. And then for some of those like this. Literally that.
That we're going to probably call it recursively.
So we'll call it we'll call something recursively on here. That will something needs to put the commas between these though. Or I guess are we using commas?
We don't have to.
Okay.
Let's see.
That would be cool if we didn't. Because then I can just copy this.
Yeah, let's copy that and try to parse it.
Yeah. Maybe without the semicolon. I need that. All right.
Okay. So if you try to compile it right now, it will probably explode with some kind of
yeah, infinite recursion or something, right? Well,
yeah.
Also we got rid of the base case where it.
Base case go. We have it at the bottom.
Okay. What? This?
Yes.
I was talking about this thing. They had like an empty. If you had passed in an empty list, you get an empty result. Okay. So what we're going to do is pick off the name and then do that. And then
okay, let me find a nice trick for debugging.
what are you talking about? This is definitely stretching my brain a little bit. Not done
Yeah.
stuff like this before. So take the name. Start. Are you assuming that we are only adding to the fun? Okay, is that why you have like the only a closed bracket here? I don't really. Are you assuming that we're going to like sort of construct the function a piece at a time?
Yes.
Okay, that makes sense. So that's why we can pass just a black box expr in the continuation.
Maybe we don't even need to accumulate expression. We can
Just
produce it
do a
as we
few
go.
recursive calls.
Yeah.
Okay.
So for recursive calls, I think it's going to be easier if we don't create a function directly, but we pass tokens as a parameter.
Okay.
So
Sure.
we're going to call it as something tokens. Or whatever the result is.
And that's because we're just going to build chunks of the function body, basically, for each
Yes.
call. That makes sense. Okay. But at the top level, we're still going to call the function name, I think, right?
Tokens.
At the top level, we still want to make a function at the end because we want like parse class decal.
Well, for now, let's start by trying to deal with this. Actually,
yeah, I think it should be like you call it like this, and then it makes a function parse class decal or whatever,
we won't be able to do it. We will be able to make function class decal.
Oh, you can't construct a new function name because that's the thing you said needed a procedural. Okay.
Yeah.
So it'll be fn class decal, whatever.
Yes.
And then the recursive macro is just called on this, and that'll take any sequence of these grammar rule tokens and then produce the body. Okay.
Yep.
All right. Makes sense.
So I guess first one we parse function name. That would be name ident. Followed by this.
Followed by
tail.
Yeah. So you can steal the signature, and then we'll make a close bracket, and we will.
And here we call it recursively with tail.
Yeah. So mixed rules. What do we want to call this macro? It's just like parse grammar rule, or
it doesn't really matter for now. Can remain.
So we will distinguish whether we're in this case versus the case of just trying to produce the function body by whether there's this
Ah.
arrow here, right?
We can. Well, first it's if this error is present. Munch tokens tail TT.
Okay.
So something like this, I suppose. And the next is going to be Munch tokens ident. Next, lit name literal lit. So this will match class, this will match this stuff, this will match this stuff. Tail TT stuff. What do we do with it? So we need to construct a rule to match the literal tokens. How do we match?
Yeah, okay, so I get what you're doing here. I don't yet see how many of these rules we're going to have to write. Like, is it one for each possible pattern, like this?
For parentheses, yes.
Okay. Do we need one for like question mark and one for star, I think.
Yeah.
Okay.
So we get this first token to match string literal. And what's the constructor name?
It's token type.
Oh.
I forgot string. And then what are we're trying to, are we building the thing that like matches and consumes, or like I don't really see how much we're doing. We're doing
to parse a literal for class.
Yeah.
So we'll compare first token. Then
We're trying to get a result at the top level. Yeah.
a result. So
Can we unambiguously know what the error is supposed to be called? Every time we match
in this case, it's expected string literal found something else.
Yeah. Okay. So, but yeah, so it'll depend. We just
Depend on the
format
branch.
it based on the first token. Okay, cool.
Yeah. No, it's not okay. Here we get a new version of tokens and call Muncher recursively with that and with the tail.
Right. Okay.
So tokens is going to be like this.
All right. All the other tokens.
Yeah.
And then this one adds to an expression. See, the way that we built this is we have an expression that we
Mhm.
start building, and then over the course of the function, the expression is constructed. So
We can pass whatever we want,
yeah,
but in this case, I don't think we even care about retaining anything. We just match the literal and pass everything else as it is.
okay. So grammar rule we call on just the
New tokens and the rest.
oh, I see. Okay, so
We'll need to pass match.
so you are using continuation then.
Yes,
Okay.
match tokens, tail, star. Something like this. It's not really happy. Okay. Let's try to call it this simplified grammar. So instead of having everything, you just make it
Mhm.
like this and see what it generates. Do you have Rust expand macro support in the Visual Studio? I don't know how to call it.
Me neither. I have a thing that called cargo expand that will do it. That will just blast it out.
That is a lot of blasting out.
Yeah, it is. Let's see. And attribute macros. All right, I'll just look at it here. Perfect. Let's see. How do we tell where it is? So macro rules is itself a macro, right? So it'll expand the macro rules into procedural macros.
Okay, that's not helping.
Yeah. Okay, so what are the things? It's right above mock syntax error. Oh, they moved that up to the top. Okay, interesting. Yeah, sorry, I don't know quick way to do it. So, I mean, I could get rid of everything.
We want to keep it.
Also, I think something's wrong with the format here. I think also we've been going longer than usual, so even though this is fun, I want to pick it up next time. But this is cool. I'm enjoying
Sounds
this.
good. Try to figure out how to have macro expansion working in Visual Studio. Rust Analyzer can help you to do it.
Yeah, I'm sure there's a way. Yeah. Okay. Thanks for the tips and stuff. All right.
Okay. See you next meeting next month.
Yeah.
Okay. Bye.
Stop recording.